To understand the distributive property, we're going to make a connection to addition problems you remember from long, long ago. Remember how easy it was to do a problem like 3 plus 3? All you had to do was think of 3 blocks plus another 3 blocks, and then count the blocks. And that's how you knew you had 6 as the sum of 3 and 3. Well, here's the interesting thing. It really doesn't matter how you arrange those blocks. We could say we have a group of 3 blocks with another group of 3 blocks right below it, and we still have 6 blocks. But now we can look at this as 2 groups of 3 blocks, which is what leads us to multiplication. Multiplication is nothing more than repeated addition. So 3 plus 3 is the same thing as 2 times 3. So now that we know that multiplication is repeated addition, let's look at those blocks a little differently. What if instead of having 3 orange blocks, we said that the 3 consisted of 2 brown blocks and 1 blue block? It's still 3 blocks, but now we can think of it as 2 plus 1. If we have 2 groups of those 3's, 2 groups of the 2 plus 1's, we know we still have 6 blocks. But now we've broken down the 3 into a 2 plus 1. So instead of saying 2 times 3, we can say 2 times 2 plus 1. We still get the same 6 blocks, don't we? We're going to make one notational change in what we've written. In algebra, letters represent variables, so the x that we've used for multiplication is something we don't want to use. So instead of writing that 2 times as 2x, we're going to take the time symbol out of it, and we're going to write our multiplication this way. Now let's look at this model again. Let's see where the brown part of the model and the blue part of the model fit into the expression we've just written. The brown part is 2 rows that each have 2 brown blocks. The blue part is 2 rows that each have 1 blue block. So what we have are 2 groups of 2 plus 2 groups of 1 to get our 6 blocks. Now focus on the equation and see how it relates to the picture. We had the brown part, which was 2 groups of 2, plus the blue part, which was 2 groups of 1. What you see going on is a multiplication that takes place over the addition. That's called the distributive property. And in the world of algebra, the distributive property is the king of all properties. Let's look at another example with numbers. 4 times the quantity 7 plus 2. For our model, we would have a rectangle that measures 4 units on one side and 7 plus 2 units on the other side. The orange part of that model has an area of 4 times 7, and the blue part has an area of 4 times 2. We want the total area, so the orange part has an area of 28, and the blue part has an area of 8. So the total area is 28 plus 8, which is 36. Since algebra uses letters to represent unknown quantities, let's see how we use the distributive property to do this multiplication. No, it's not going to be any more difficult. Just watch. Here's what the model would look like. It's 4 units on one side and x plus 2 units on the other side. The area of the orange part of the model is 4 times x, and the area of the blue part is 4 times 2. So the total area is 4x plus 8. That wasn't so hard, was it? Of course it wasn't. It's just the distributive property. Now let's try another one. What if we change that to 4 times the quantity x minus 2? Does that change anything? Well, not really. Here's what our model looks like. It measures 4 units on one side, x minus 2 units on the other side. The area of the orange part is 4 times x, minus the area of the blue part, which is 8. So our total area is 4x minus 8. One last example. What if we have x times x plus 2? We have variables in both dimensions of our rectangle. It's still the distributive property. We have a rectangle that measures x in one dimension and x plus 2 in the other dimension. To find the total area, we can find the area of the orange part with x times x and the area of the blue part with x times 2. So our total area is x squared for the orange part plus 2x for the blue part. Total area is x squared plus 2x. So what do you think? Can you do the distributive property on your own? Yeah, I thought so. It's not that difficult. It's just multiplication.